when you're thinking about removing item, you have to think about branches. The branches represent the option. So you might think three choice meaning what's going to be third branch. No, the first choice is this. Removing three items meaning if you remove the first item, it can either be red and blue. There cannot be more than two branches because there are two options. Each branch represent an option. So after this is done, now you're going to choose the second item. So the second item can either be a red or a blue. So it can be a red or it can be a blue. So remember, every branch represents an option. So again, it can be a red or a blue. So it can be a red or a blue. So that is the second item that is being removed. Now what about the third item that's being removed? Well, the third item, again, it can be a red or it can be a blue. Then it can, again, here it can be a red or it can be a blue. It can be a red or it can be a blue. It can be a red or it can be a blue, and on. That's how it goes. So red, 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 blue, blue, blue. So this is a little bit more complicated than having removing two items. So the tree diagram will be like this. Now if you want to fill up the table, so this calculation is going to be, so out of the first red, there are 8 red and we have 15. So 8 out of 15. Now in case of blue, the first blue is 7 out of 15. Now once you have a red, the second red is going to be reduced by 1. So it's going to be 14 item, and even red is going to be reduced by 1. So 7 by 14. And the third one is going to be 13 item, since 2 item has been removed out of 15 items and 2 reds has been removed. So now there's going to be only 6 red. This will be 6 by 13. Now in case of blue, we have 7 by 15. So this will be 14. So 6 by 14. Then 2 blues have been removed. This will be 13. So that means 5 by 13. So from the third blue, if you have already removed 2 blue, now that means there are 5 blues left. So 5 out of, even the total is less by 2. So 5 out of 13. Now what we have is, if we take a red and then we take another red, so 2 reds have already gone, so now the third one has to be a blue. So this is going to be 13 items. So since we haven't removed any blue at all, we have only removed 2 red, this will be 7 out of 13. Again, if you have removed a red and then a blue, so what would happen to this red? Well, the total is going to be 13 because 2 items have been removed and only 1 red has been removed, so this will be 7 out of 13. If we had removed 1 red and 1 blue, so the total would be 13 since 2 items has been removed, and here 1 blue has been removed, so this will be 6 out of 13. Again, if a blue has been removed and another red has been removed, what would be over here by the third item? So 13 items are there and 1 red has already been removed, so this will be 7 out of 13. Again, if you have a blue item removed and a red item removed, what would be here? So this would be 13 because 2 items have been removed, and then this is going to be 1 blue has already been removed, so this is going to be 6 out of 13. It's a bit lengthy. So when you have 2 blues removed and the third one is a red, so the total will be 13, and out of this 13 no red has still been removed, so this will be 8 out of 13. So this is how it goes. Sample space. So this tree diagram gives us an idea to take a look at what can be the sample space. So the sample space here, red, 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 and here blue, blue, blue. Then the sample space through this line is red, red, blue. So red, red, blue. And then the sample space over here is red, blue, red. So red, blue, red. Then the sample space over here is red, blue, blue. So sample space over here is red, blue, blue. You don't have to write the sample space. I'm just writing it down to show clearly what are the possibilities over here, because tree diagrams gives us a chance to look at every option. So then we have this one, blue, red, red. So this is blue, red, red. And then we have blue, red, blue. So we have blue, red, blue. Then we have blue, blue, red. So blue, blue, red. Of course, when you do the math yourself, you're not going to write all of these out because it's going to take some time. So the idea is just to have an idea what it looks like, so that when you do the math, it is easy for you to understand what's going on. So these are all the possibilities. From the tree diagram, we can see these are the possibilities. There are no other possibilities other than these. So when the question comes, so find the probability of same color. So in that case, what we can have is, so probability of same color. So there are only two options: red, 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 or blue, blue, blue. Two permutations: red and red and red, or blue and blue and blue. So that's same color. Now, if the question is find the probability of different color, let's check from the previous type of question. When you have two options and you're removing two items, then different color means not same color. That means you can either consider red and blue or blue and red. That's it. So that means different color and not same color, meaning it will not be red and red or blue and blue. But here you have to see there are no possibility for different color. As a matter of fact, this question itself is wrong. This question itself is wrong. Take a look at this. Red, red, blue. This is not different color, because different color means each and every item has to be different. So this is not same color, but this is not different color, because we have two red, one blue. So for different color, each and every one of the item is going to be different. So it's not possible to have different color. So this question by itself is wrong over here, and this question is not valid. So if they had asked the question, find the probability not same color, then this question would be valid. So you can say not same color means red, red, blue, red, blue, red, red, blue, 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 red, red, blue, red, blue. All these are not same color, but are they different color? Different color means each and every item would be different, and that's not true over here. So this question itself is not valid. It's not right at all. Now another common question is find the probability that there are at least, so at least two blue. So okay, at least two blue means there can be more than two blue, but there cannot be less than two blue. Let's see what are at least two blue. So we have two blue over here, so red, blue, blue. We have two blue over here, blue, red, blue. We have two blue over here, blue, blue, red, and we have two blue over here, blue, blue, blue. That means these are all the permutations that are possible. So one item is two blue, one red, and its permutations. That means red, blue, blue, then blue, red, blue. So all the permutations of two blue, one red, and then we have this one which is blue, blue, blue. So that is going to give us all the permutations that are possible for at least two blue, and it is very easy to see from the tree diagram. Now there is one more question, and the question is pretty straightforward. This particular question does not require any permutation, and this question goes like this: find that there are blue, blue, red in that order. This is one question. So that means do not consider any permutations, blue, blue, red in that order. So the permutation, there is no going to be no permutation. It will be blue and red. That's it. End of story. And another question is find the probability of blue, blue, red in any order. In this case, you have to take all the permutations, and the permutations are blue, blue, red, red, blue, blue, or blue, red, blue. That's the question. And one more thing, as I have mentioned before, every permutation will have the same probability. That means if the probability of blue, blue, red is P, then the probability of red, blue, blue will also be P, and the probability of blue, red, blue will also be P. That means by doing the permutations, instead of adding P plus P plus P, you can just write 3P. So that is going to be the overall probability of this permutation, blue, blue, red, or blue, red, red, blue, blue, or blue, red, blue. All of these is going to be P plus P plus P, or basically 3P, and then you find the probability of this. Suppose this probability of Q, so the overall probability is 3P plus Q.